Welcome back, Algebra 2.1 students. This is now the start of Unit 1 of Algebra 2. Equations and functions, we're going to set the review aside from Algebra 1, and now we're getting into Algebra 2 type stuff. So the first thing I want to do is go through the bell work, where we're going to go through the most missed questions from last Friday's Algebra 1 quiz. We're going to go through the objective and the essential question. What are arithmetic sequences? How are they used? How can I calculate them? And so forth. And then we're going to obviously go through the arithmetic sequences. We're going to see what an explicit formula is, what's the common difference, how they relate to functions and equations. Why are we doing sequences? If it's equations and functions, Mr. Carlson, we'll figure that out. And then we're going to go through the summary, the closure, the homework. So let's get started. These are the 4 questions that we missed the most on the Algebra 1 quiz last Friday. These 4 questions. So, if you want to know how to do these 4 questions, pause the video, try your best. I would challenge you, try your best to get as far as you possibly can on these questions, and then come back, and I'll show you how. If you need to retake the Algebra 1 quiz, you need to email me pronto so that I can open it up. So obviously then you can do it, okay? If you took the quiz on Friday, you have until next Friday to complete it, all right? So that would be this upcoming Friday when you're watching this video. This is Monday if you're watching this, it's this Friday, okay? So in general, if you take it whatever day you take it, you have exactly 1 week to make that up if you need to retake it, but you need to communicate to me. So go ahead and pause the video and then try your best and let's get started. All right, let's go to town. Now, how do I solve this? This is an absolute value inequality, and this one is also an absolute value inequality. The first thing I noticed, the very first thing, is this is not isolated. The absolute value part, the 5 minus x, is not by itself. That part needs to be by itself before you do anything. So what do I do? Well, first of all, I have to divide by -4. Okay, I have to divide by -4. Why is that, Mr. Carlson? Great question, kids. It's because this is multiplied right here. The opposite of multiplication is, of course, division, so I have to divide to undo the multiplication property. Now, here's the interesting thing. Because it is an inequality, what happens to the sign? It flips. So yes, of course, I still have the absolute value of 5 minus x, but then this sign here flips into becoming this sign. Not less than, but greater than. Okay, that's the number one thing I have to understand. And then this, of course, is just 2. -8 divided by -4 is just 2. So now we have to ask, okay, great. We flip the sign, we divide by the -4. Is it isolated? Is the absolute value part isolated? And we can say, yes, it is isolated. The 5 minus x, the absolute value of that, is by itself on the left side. We're solid. So now what do? I can make this into 2 separate equations. Now, inequalities, 2 separate inequalities. Now, why would I want to do that? Well, first off, I need to understand that this is now a greater than sign, not a less than sign. So, because it's a greater than sign, I'm going to solve it as a greater than sign tells me to solve it. What does that mean? It means the first inequality that I have is exactly how I see it. Nothing changed except for there's no absolute value bars at all. It's the very first one. See how these are the exact same, besides the fact that I don't have any absolute value bars. Now, the second inequality is literally the exact same thing, besides the fact that it doesn't have absolute value bars, but it also changes the sign and tags on a negative, okay, to that constant. So notice how this was a greater than, and now it is a less than again, okay? And so you change this sign by following the rules of the game. That's what Einstein says. Math is just following the rules of the game so that you can get the correct answer. The rule says whenever you have a greater than sign, you have two inequalities. One is exactly how you see it, except for the absolute value bars. The second one is exactly how you see it, except for you have a change sign and then a negative. A changed inequality sign and negative. Now that we got through that, we can actually start solving this beast, both of them. So how do I get x by itself? I minus the 5. I'm not going to show that, besides maybe right here, just minus the 5, and that becomes negative 3. Now, what do I do here? It's a negative x. How can I get by itself? I have to divide by negative 1. I have to divide by negative 1. What I do to one side, I must do to the other. The negatives go poofy, and then I'm left with x, and this is 3, because negative 3 divided by negative 1 is 3. But what about this greater than sign? You should be guessing it already. You divided by a negative, therefore it flips the sign again. And you're like, again, Mr. Carlson, again? Yes, kids, again, okay? You have to flip it however many times the problem asks you to flip it. You're following the rules of the game. You don't just get to decide when you flip it. Okay, I flip it if I do certain things, and one of those things is divide by negative. I divided by a negative, therefore I flip. Okay, it's not like cheating Monopoly. You actually have to play the rules of mathematics to get the right answer. Okay, now what about this one? This second one here. The second one is, of course, I minus the 5 just like normal. So negative x is less than. This becomes negative 7. But then we start to see, oh my goodness, it's going to be the exact same thing. And so now my answer is x. Flip the sign right here. Flip the sign. So now it's going to be greater than, and I have 7. Because negative 7 divided by negative 1 is 7. So these are my two answers. X is less than 3 and x is greater than 7. If it doesn't ask us to graph it, but if I wanted to graph it really quick, this is going to be a 3, this is a 7, open, it goes, I'll do this in blue here. See Spider-Man colors, everyone loves Spider-Man, right? They should. Points over there, and then this is a 7, and then it points over here. What does that look like with regards to domain interval notation? Negative infinity to 3, union, and then 7 to positive infinity. Remember, read left to right. And this is only towards domain interval notation. So the interval notation, I read it left to right. Well, it should actually be that way, right? So left to right, okay? Good deal? Good deal. It doesn't ask for that, but I just decided to do that just because to show you the review. Let's go to this one. Solve the absolute value inequality. First things first, is it isolated? You should say no. And I should next see that this is multiplied by 2 and this is added. Personally, me, I like to subtract first, okay? Because it's easier. And so I'm just going to carry everything down. This is greater than, and then when I subtract this, this is 2. So the 6's go poofy. Yay. Okay, and now I need to divide by 2, because again, that's multiplied. Divide by 2, that goes poofy. And I have the absolute value of 2x minus 3, and this is greater than 1. Now it's greater than sign, which means if it's a greater than sign, we're going to solve it like a greater than sign, just like what we did right here with my little cursor. Okay, so that means I have one inequality exactly how I see it, except for the fact that I don't have any absolute value bars. The second inequality is exactly how I see it, except for the fact a couple of things are going to change. So let's do purple. Okay, the inequality itself changes, and then I tag on a negative. I only do that with greater than signs. Okay, I think we kind of understood the less than signs, but when it came to the greater than signs, we were like, what? Okay, so let's solve this. Plus 3, so I have 2x greater than plus 3 is 4, and so x is greater than 2. And then this right here, if I plus the 3 over, I have 2x is less than, if I plus the 3 over, guys, think with me. If I plus the 3 over, that's a 3, I promise. Okay, then that means this will actually be 2, divide by 2, divide by 2, so x is less than 1. That is my second answer. So those are my answers. What does it look like on a number line? Really, really quick. Let's go fast. So this is going to be 1, and this is 2. This is open, open. The 2 points that way, and then the 1 points this way. So what does that look like with domain interval notation? Very similar to my last problem here. Negative infinity, because negative infinity is all the way over here. All the way going to, where do we stop? 1. That's where the graph exists, but we stop at 1 because it actually doesn't exist there. Okay, so I have these two answers, negative infinity to 1, that's where the graph exists. Let's go to the union. And then 2 going to positive infinity. That's my infinity sign, I promise. And if some of you are thinking like, wow, that's kind of a weird break, how did he edit that? I just paused the video because Davenport was talking to me, so. All right, so those are the two answers. Mainly, I'm just focused on these boxes down here, and these are the interval notations with the graphs. But didn't ask us for that, but I did them anyways. Because I'm so awesome, right? Take a minute, pause the video, get those down. I will erase. Let's go on and go through these. All right, linear equation and then another absolute value, but this time it's an equation, absolute value equation. So let's get to it. Solve and check the linear equations. Well, first things first, I need to distribute all of this, even this one. And this is a 1, so let's distribute. A lot of you missed this, surprisingly. I felt kind of bad inside. I was like, oh, shoot. Okay, so this is going to be 6x minus 42 minus 7x and then plus 42. Plus 42 equals. This is going to be x plus 6 minus x and then plus 3. All right, so now let's start combining like terms here. Remember, I'm going to focus on either side before I start switching stuff over. Okay, that's what I want to do. Focus on either side before I start switching stuff over, which means I can focus on this, I can focus on that. And then these are really nice. Look at this. I have a negative 42 and a positive 42, which we already should know. They go straight up poofy. If I have a minus 42 and a plus 42, it's like a hole, but then you fill in the hole, it's level ground. It makes 0. Okay? What does the 6x minus 7x equal? This is actually going to be negative x, just negative x, because what is 6 minus 7? Negative 1. Tag on the x, we take negative 1x, but we don't write the 1, negative x. This equals, what happens to the x's here? This is another fascinating case of poofiness. So that means that goes poofy. What happens to the positive 6 and plus 3? That gives me a 9. What do I do here? Well, remember, this is technically understood 1, so divide by negative 1, divide by negative 1, that goes poofy, and then x equals negative 9. That is my answer. Perfect. Perfect. Let's go to the next one. This one's a little bit difficult. It looks difficult, but it's actually really not. We still solve it just like absolute value equations, but again, we have to follow the rules of the game. The rule of the game says if the left side, specifically the left side right here, is isolated, if that part is by itself, then you can separate your absolute value equation into two separate equations. What's the first one? The first one is literally exactly how I see it, except for the fact that I don't have any absolute value bars. Okay, great, that one's easy. Second one, exactly how I see it, except for the fact I don't have any absolute value bars. But one catch. Has one catch. And it's this one right here. I have to put this in parentheses and then negative. Usually this is a constant, right? Usually we say equals and then we just tag on that negative. Let's just say it was 7. We would tag on that negative, right? But notice how we don't ever write parentheses around this. What we're really doing is tagging on the negative to the entire other side. but we never really needed to use parentheses until now. We still tag on the negative, but not just to the constant, to the 2x as well. So we need to make sure we put parentheses there. So let's start solving this, the first one first, and then we'll go to the second one, and we'll go to town. Finding our answers, because that's what we do. Okay, what can I do? I'm going to look at this 2x, and I'm going to subtract it here. I'm going to look at this negative 20. I'm going to add it over here. So 2x subtract, which gives me 6x. 8x minus 2x, when I move it over, gives me 6x. And then the negative 20, when I move it over, it becomes a positive. So plus 20. So 3 plus 20 gives me 23. Okay? This isn't a nice fraction, to be honest. It's actually a rather gross looking one. But I got 23 all over 6 when I divide by 6. That's okay. Let's go to the next one. I have to distribute that 1. This is 8x minus 20. That just chills. And then this is negative 2x and then minus 3. Let's start combining this stuff here. Let's move that negative 2x over. So we add it now. So that will become 10x. So 8x plus, when we move it over, plus 8x. And then we'll move this negative 20 all over here. So let's add it. So this will be negative 3 plus 20, which is going to be 17. Negative 3 plus 20 gives me 17. So again, not a great looking fraction here. But, I mean, still an answer, right? So I got 17 all over 10. And I don't need to graph these because I don't need to graph any of these, like this first one and this whole absolute value equation, because it's an equation. We don't graph equations. All right. That's it. Those are the 4 questions I wanted to get through with the Algebra 1 quiz. Remember, retakes are due whenever you need it. Please just email me. Let's erase. Let's get started on the arithmetic sequences. Our lesson for today, what is arithmetic sequences and how do I write formulas for them with a SpongeBob face? Okay, let's get started. If you need to write it down, just go back, pause the video. We're going to do a lot of arithmetic sequences. This whole week is going to really be sequences and functions. How do sequences relate to functions? Let's try to find out. Write down each of these sequences, their rule, pattern, and then list the next 3 terms. Okay, so this is a sequence. Let's see if we can list the next 3 terms here. 142, 146, 150, 154, and 158. What's going on here? What's the pattern? You should be thinking that the pattern is very constant. And by constant, I mean it is plus 4 every single time. So plus 4, plus 4, plus 4. So what is the next one? Of course, 162. What's the next one? 166. Okay, and what's the next one? It's going to be 170. That's the next 3 terms. All right, what about this one? 5, 2, negative 1, negative 3, negative 4, negative 7. Not negative 3. Negative 4, negative 7. What's the pattern? Hopefully we can get it. You should say negative 3, minus 3, minus 3, and then minus 3. So minus 3 on each gives me the next preceding term. So what if I do minus 3 here? I get negative 10. Another minus 3 gives me negative 13. Another minus 3 gives me negative 16. Those are the next 3 terms. And what about this one? I have 8, 3, negative 2, negative 7, negative 12. What do I have? Something very similar to this second one here. I have minus 5, minus 5, minus 5, minus 5. So if I do minus 5 again, what do I get? Negative 17. Again, I get negative 22. Again, what do I get? Negative 27. Okay? Negative 27. Sweet. So this is what I have with regards to a sequence and a pattern. This is what we call the rule. their pattern. And this is a sequence. Okay, these are sequences. All right. I'm actually going to leave it. So here is what arithmetic sequence is. They're called these arithmetic sequences because you get each succeeding term by adding or subtracting the constant amount, okay, called the common difference. So what is the common difference in this first problem? Our common difference, or D, equals 4. What about the second one? D equals -3. Third one, D equals -5. These are my common differences in each of the sequences that can be found within the pattern. Okay? So let's erase and move on to the next one. Oh, and by the way, if you have yet to complete the absolute value inequalities on Desmos.com, the Desmos activity, here it is. I know it's kind of embedded. Maybe some of you are still watching this video and you're like, holy crap, I didn't even do that. Please do it. Okay, so here it is. Go to student.desmos.com and then type in this code, please. Pause the video if you need to. Okay, great. All right, let's continue. I know I needed to kind of give you a reminder here. So I want to know the first 5 terms of the arithmetic sequence whose first term, whose very first number is 5 and the common difference is 9. How can I do this? Let's find out, kids. Okay, so the first thing, I'm going to write it like this. I'm going to use some sequence notation here, some sequence mathematical notation. I'm going to teach it to you because math is a language and I need to teach you the language in order for you to understand how to do it, how to say it, how to work it. Okay? So when I say the first 5 terms and then whose first term is 5, I'm going to signify the first term to be 5, saying A sub 1 equals 5. So an A, that's my A's. I know they look weird, but that's my A. And then this is 1 because it's the first term equals is 5. Why is it A, you ask? I have no idea. Arithmetic sequences for a reason. So A sub 1, or A1 for short, so A1 equals 5, like A1 steak sauce. Boom. Okay, what we want to know is this. What the junk is A sub 2? We're given another thing though. I'm going to put it over here with my little variables. This is like a little squiggly, by the way. It's a little squiggly thing. I put it there so I'm not like confused. I have all my variables present. They say D, my common difference, is 9. So I'm going to say my D is 9. Now, just like in the last slide, when we had a sequence of terms, they each common difference, by that number. If my common difference is positive 9, what do you think the next term will be for A sub 2? You should be screaming right now. That is literally going to be 5 plus 9, which equals 14. Okay? It should be 14. Now what about A sub 3? Again, A sub 3 is just the consequent of the preceding terms. When I take this term, 14, and then plus 9. What does that equal? This equals 13. Whoops, not 13, 23. 23. Forgot to add that in. Okay, that's a 2, by the way. Let's go to the next one's a little bit faster here. Let's go to A sub 4. What is A sub 4? Well, if I take 23 and then I plus 9, what does that equal? It will be 33. Okay? 32. Jeez, I'm awful at this thing. Let's just erase this. Let's just do 32. Boom. Okay? Man, I guess it's not my time. So a sub 5, let's do that. A sub 5, what is that? Well, I take the preceding term, which is 32. Okay, 32. So far, so good. Just take the preceding term and I add 9 to that. What is that going to be? This is 41. Okay. So what does this mean? What did I just do? I'm going to kind of put it in a string for you. Okay. My first term is 5. What's my second term? 14. My third term, 23. My fourth term is 32. And then my fifth term is 41. Can this go on forever? Absolutely. So this right here is what my sequence is. Now, if you're saying, like, I don't get the a sub 1s and the a sub 2s, this right here, that right there, that 5, that's a sub 1. This one is a sub 2. This 23 is a sub 3. This right here is a sub 4. And this is a sub 5. Okay? So, and they go from each one. So when I say a sub 1, I'm saying this is the first term. This 5 is the very first number of this arithmetic sequence. That's what I'm saying. Okay. Now, let's go to the next one. I want to erase this here, of course. So let's erase. This next one says, write the first 6 terms this time, the first 6 terms of the arithmetic sequence. So they don't necessarily give us an actual sequence of numbers like I just wrote down right here that I'm currently erasing. What I'm erasing is the actual sequence of numbers. They didn't give us that, but instead what they gave us is a couple variables. So in the first problem here, we didn't need a sequence of terms, actual term by term. We had to find that out, and they gave us the variables, but just by stating them. And here they actually give us what the first term is. So this right here, I'm just going to remind you, this is what the first term is. So first term is a sub 1. My handwriting looks awful, but I promise it's way prettier in person. A sub 1, first term. D, that's my common difference. I'm not going to write common difference. I'm just going to abbreviate and just say diff. How about that? Okay, so how do I kind of go about getting my next term, specifically a sub 2? Well, I take the previous term, a sub 1, 9 over 2, and then I subtract, in this case, subtract because it's minus, subtraction, subtract the common difference here. So what does this equal? It just so happens that these are common denominators, and I can now perform fraction arithmetic on them, specifically subtraction. So 9 minus 1 is 8 all over 2, which equals, simplified, 4. So what's my second term? 4. What's my third term? This is a little bit more confusing. Now, some of you may be thinking, okay, let's take the 4 and put it here. We could, but remember, we have to subtract 1/2. And 4 and 1/2 do not have common denominators. So I want a number that's equivalent to 4, but has a common denominator already for negative 1/2. What is that number? That number is something that we've already done. We've already written down. This number right here, 8 all over 2. 8 over 2 is equivalent to 4, but it still has the common denominator of 2. So when I do my common difference, minus 1/2, I don't have to look at that 4 and kind of times by 2 and everything and try to get it to be the exact same common denominator. It's already the common denominator, so I can just straight up go to town on subtracting these. 8 minus 1, that is 7, all over 2. This is my third term. What is my fourth term here? So a sub 4. Let's start hashing these out. I'm going to take 7 all over 2 and then minus my common difference, which is 1/2. 7 minus 1 is 6 divided by 2 equals 3. Notice how it's kind of skipping here. They first gave us a fraction and then a whole number. Fraction, then whole number. So when I do a sub 5, do you think I'll get a fraction or a whole number? I should get a fraction. Okay, I want to take, because this is my common difference, so I want to take 6 over 2 this time. Why do I want to take 6 over 2? Because when I subtract my common difference of 1/2, I already, at the very beginning, have that common denominator. So 6 minus 1 equals 5 all over 2. This is my fifth term. Notice how we said it was going to be a fraction, and we were right. I think they said 6 terms, so let's do this one really quick. Let's do a sub 6. Let's take my previous term, 5 over 2, and then I want to do minus 1/2. What does that equal? This is going to be equal to 4 over 2, which equals 2. Okay? So what's my sequence? All together, what my sequence is in purple, because it's everyone's favorite color. My a sub 1 is 9 all over 2. And then comma, what's my a sub 2? It is 4. And then I have 7 all over 2. And then I have 3. I have 5 all over 2. And then I have 2. Can this go on forever? Obviously, it can go on forever. But this right here is the first term. I'll put it in red. This is the first term. This is the second term, third, fourth, fifth, and sixth term. And it can go on forever. Remember Smalls from Sandlot? Forever. Forever. Yeah, you get me. All right, let's erase. What is actually happening here? Let's try to develop an actual formula, because this is a pattern. Okay, arithmetic sequences are patterns. Let's develop a formula. It's what we call recursive formula, and it looks something like this. A sub n, okay, it's sub, so it's kind of underneath. A sub n equals a sub n minus 1 plus d. What is my d? Of course, it's my common difference. What does recursive mean? Great question. Recursive means going backwards or from the previous. Okay? So if I do cursive handwriting, I am building and moving forward. If I do recursive, I have to do it again and I have to go backwards. If I retie my shoe, I have to start over again. Okay? If I watch a rerun, it is something that's already occurred, but then they're going back and rerunning the show. Okay? So that's what re means, and then cursive just means going forward. So it's basically redoing the problem. Okay? How does that work? Well, first off, I'm going to tell you, we don't usually use this recursive formula. Like, I will never actually really use this formula because it's so intuitive. How do you know it's intuitive? We already did it in the last slide, and we didn't even have a formula. And you're like, really? I'm like, really? Okay, how do I know? Look at this problem. Is this not the exact same question that I had in the last slide in the first question? Yes, it's just different numbers. So look at it. Find the first 5 terms whose arithmetic sequence is first term, whose first term is 6, whose common difference is -8. So I usually do my little squiggly thing here. Let's define our variables. A sub 1 equals 6. What is my common difference? My common difference is 8. They told us this. And we already did this in the last slide. Yes? Yes. So now, what do? If I wanted to follow the formula exactly, okay, a sub n, this n just means any number. So this n right here just means a number. What number? Well, I want to find the first 5 terms. What's next? 2. So I want to find 2. Okay, it's the second term. So watch. N now equals 2 in this case. N will now equal 2. So watch. A sub 2 equals, I'm following my formula step by step. I'm going to write this down. A 2 minus 1. N minus 1. If n is 2, I'm going to put 2 there. So 2 minus 1. And then what's my common difference? My common difference is -8. Now, what does this look like? What is 2 minus 1? Let's solve this. So I have a, 2 minus 1 is 1. 2 minus 1 right here is 1 minus 8. Okay, a sub 2 is still chilling here. I'm just bringing it down. The only thing I did right here was this. That's the only thing I did. Now watch. Ready? So this is a sub 2 equals, what's a sub 1? Don't you already have a sub 1 right here? Yes. So you're literally going to implant a sub 1 right there, which is 6, and then minus 8, which equals negative 2. Now watch. We already did that in the last slide. Intuitively, we took the preceding term, in this case, our preceding term from a sub 2, the one that comes before it, the term that comes before a sub 2 is a sub 1. What is a sub 1? It is 6. Okay? I take that term and I add or subtract the common difference. So this arithmetic sequence recursive formula, this actual recursive formula here, is really just so intuitive that yes, this is the formula. However, we really don't use the actual formula as I used it right here. So am I going to use the formula to find a sub 3? No, because we already know I take the preceding term, which now in this case, it's negative 2. That's the last term that I found. And then, of course, I add or subtract the common difference. In this case, it's negative 8. So negative 2 minus 8 equals negative 10. Okay? Now, if I continue, a sub 4, this will be negative 10 minus 8. Even though I'm not writing down my actual formula like I did here, I'm still using it. And then I'll do a sub 5 over here. This is negative 18, negative 18, and then minus 8. This is negative 26. That is my fifth term. And I found all 5 terms. A sub 1 is here, a sub 2 is this, a sub 3, a sub 4, a sub 5. How do they look like? What do they look like when I put them in a sequence? So 6 minus 2 minus 10 minus 18, and then minus 26. On the very first slide, guys, I asked you, what's the pattern here? And I assume some of you caught the pattern, and this is minus 8, minus 8, minus 8, minus 8, and we could figure out the next numbers, right? We were doing math. We were doing the recursive formula before you even knew what it was. Okay? It differs commonly, negative 8 differs throughout the whole sequence. It's sort of like a constant. Okay? It's a constant slope, if it were. Okay? Think about that. It's a constant slope, if it were. Okay? It keeps going at the same rate. So maybe some of your Algebra 1 stuff is trickling in the back. Maybe not. Maybe you're like, who the junk does this guy think he is? I'm going to erase, by the way. I think I'm a math teacher who knows what he's talking about. So let's go through this, okay? What is this one? Now, this one looks a little bit confusing, but it's actually not. I told you I was not going to use the recursive formula. However, sometimes Math Excel will want to use the recursive formula. And by using the recursive formula, I mean this. It will actually give you something that looks like that. Isn't that the recursive formula? A sub n equals a sub n minus 1, and then something. Now watch this. All we need to do to find the first 6 terms is we need 2 variables. Number 1, we need our a sub 1, which in this case, they already gave it to us. It's 31. Ha! Okay, that's easy. All right, but what's my d? What's my common difference? I need that in order to solve for my sequence, to find the first 5 terms. What do I do? Well, here is the key. This corresponds to this number. And this number, which in this case is a variable, is what? D. So then what is my D my d is negative 13 because this formula is literally this formula. The only difference is what? The negative 13 is in place of the d. So that means the d, this d variable is negative 13. Okay, I have my two variables now. Awesome. So now we can start going to town. So let's do this fast. A sub 2, I have 31. That's my first term, the previous term, minus 13. 31 minus 13 gives me what? You should be saying 18. Okay, what is a sub 3? I have 18 and then minus 13. What does that give me? Should say 5. You're correct. A sub 4. Let's take 5 minus 13. This gives me negative 8. And then let's take a sub 5. This is going to be negative 8 minus 13. What is this? Negative 21. Box it. And then our last and final sixth term, what is it? I take negative 21 minus 13 because, again, that's my common difference. This equals negative 34. So that's my first term, a sub 1 equals 31. Second term, 18, third, 5, fourth, negative 8, fifth, negative 21, sixth, negative 34. That is the recursive formula. Okay, let's erase. Now let's get to what we call the explicit formula. What is the explicit, or sometimes called the general term formula? Well, let me ask you a question. Have you ever bought music that says explicit on it? Like Taylor Swift's new album, it has a couple of songs that say explicit. What does that mean? Now, if you're thinking, it means swear words, Mr. Carlson. Sort of. Okay? When I say explicit, I mean clear. Explicitly clear. It means there's no hiddenness. She just goes out and says it. Okay? So when a song or an album says explicit parental advisory, it means they just say whatever they want in that moment. And most of the time, yes, it is a swear word, obviously. Okay, some colorful language there. Now, what does it mean for math? In this case, it does mean sort of the same thing. It just means specific term. So it's very specific. Okay? So when I say explicit, it means specific. Okay, the opposite of explicit means implicit, which is not specific, but we want specific. Now, you may see this and you're like, what the junk? Don't get your man bun in a wad, okay? Now, this is what it is. This is the one that I will be using. Whoops. I almost cut that out. This is the one that I will be using. These are two formulas. So I can use this one or I can use this one, okay? Now, the reason why I cloud this one, because personally, I already have it memorized. I've been doing this so long. And because personally, I think it's easier. You may disagree. If you want to use this formula, you can. I will actually show you both in just this first example, but then I'll drop this second one and I'll only do this one. Okay? Say it again. I'll do both in the first example. Both will get you the right answer. But I mainly use this one right here, and because I'm going to use this one, I will more than likely not do this one ever again. But do they mean the same thing? Yes, they do. So find the 15th term of the arithmetic sequence whose first term is this, 7. Common difference is -2. Okay, so the first thing I like to do is always, for me at least, is to label my variables. So I have my variable, first term, a sub 1 equals 7. My next variable that is given to me is d, and this is labeled as -2. Now, here's the difference. Now, notice this. It wants us to find the 15th term. Now, before it was asking find the first 6 or find the first 5 terms, right? But now, and we had to use the recursive formula intuitively or actually use the formula. We could do that. But now, notice it's the first 15th term, or to find the 15th term. Now, one way to do that is literally just add or subtract 2 from 7 over and over and over again. So you can get your little calculator out. 7 minus 2 equals minus 2, minus 2. Enter, 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 enter. Like, you could do that. Why would you want to do that if you can use a formula? I literally have students sometimes in my class just straight up just enter, 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 and they're counting in their head. 15, that's a number. Okay, great. And then they're writing it down. Are you for real? You're joking me, really? Like, you're out to lunch, I'm telling you, because that's crazy. I'm telling you a formula that actually solves that problem. Someone developed this formula, so that you would not have to do that. And these kids are still using it. Girl, please, okay? So that's my first step. If you like steps, you can write a 1 here. What is my second step? My second step, okay? My second step is to start plugging this stuff into the formula. I want to find the 15th term. So when I say, what is a sub 15, I do a question mark. I don't know. Let's find out. So this is a sub 15 equals, I'm following this formula. I'm going to do this first one, okay? Just going to do this first one. What is a sub 1? We already know, so it's going to be 7. I'm just going to put 7 right there. Plus, because that's what my formula says, plus parentheses. Why are you going to do parentheses, Mr. Carlson? I hate math, blah, blah, blah. Look, parentheses, okay? I'm just following the formula. I'm not, like, taking this stuff out of my butt, all right? I'm serious. It's following the formula. Parentheses, what's n? N is, in this case, 15. Because we want to find the 15th term, so n is 15, so I put 15 here, okay? And then minus 1, and then in parentheses. And then times, what's my d value? My d value is -2. Now notice my parentheses here. Parentheses are your very best friend, I'm telling you, okay? Because now you can just plug this all straight up in your calculator and you would get the right answer, but we're going to do it by hand. Okay, this is 7 plus, in parentheses, this is 14, and then times -2. Okay, this is 7. What's 14 times -2? That's going to be right here. This is going to be negative 28. Sorry. -28, and then plus 7, which is going to be -21. This is my final answer. What does that mean? This means this is the 15th term. That's what that means. It's the 15th term. Okay? 15th term. Now, I did that pretty fast, moderately fast. I'm going to take a break right here and do red, which means I'm going to do it this other one. I'll show you they get the same answer. This is the only time I'm going to do it this way. Okay? Only time I'm doing it that way. So now I have a sub 15, because n is 15, d times n. What's my d? My d is -2. What's my n? In this case, my n was 15. Okay? And then plus, because my plus, parentheses, my a sub 1 is 7. That's what we said all the way over there. And then minus my d is -2. Now watch what I do here. Parentheses. And then close it. Why do I do that? Because you're doing a minus that's built into the equation. The minus is built into the equation. By the way, that's one of the reasons why I don't do this formula, because students just have a hard time doing that. You don't have to deal with it this way. Okay, but this way you do have a hard time dealing with it. Okay? So, built into the equation, so what is this? This is -30 plus, these become positive. Negative times a negative is a positive. So 7 plus 2 is going to be 9. Negative 30 plus 9 equals negative 21. Now notice, did I get the same thing? Yes, because both work. Which one am I going to use? I'm going to use 1 from here on out. You can use 2 if you want, but I'm not going to. So let's go through a couple more examples because that is my 15th term. I used the formula. Now, if you really wanted to, type 7 in and just do negative 2, minus 2, minus 2, minus 2, minus 2, minus 2. 15 different times, you'll get this, okay? But I'm telling you to use your formula. So let's erase this. And let's go to this one right here, okay? I'm going to go through this one just a tad bit faster. It's the 7th term, so that means n equals 7. And I'm going to plug 7 in for this formula right here. This is the one I'm going to use eventually. And then the arithmetic sequence of 0, 13, and 26. Now, here's the difference. They don't give us the first term, like a sub 1 is this, and they don't give us a common difference, which means we have to find that out. So let's go over here. Let's list out our variables. I already have n equals 7. What's my first term? My first term is literally hidden in plain sight. It is this first number. That is my first term. Who would have thunk? The first term is the first number. Okay, so a sub 1 is 0, so I'm going to write that down. And then what is my common difference? Same thing. How do I get from 0 to 13, 13 to 26? You should say plus 13. So that means it's plus 13. Now, let's go to my formula. What's my n? I want to find a sub 7. A sub 7 equals my first term right here, which we found would be 0. Oh, that's glorious. Look at that. Plus, because my formula says plus, my parentheses. What's my n? We said 7. Minus, because the equation has minus, 1, and then parentheses. What is my common difference? I'm glad you asked. Times 13. Now, I usually put this common difference in parentheses here, because just in case I have a negative with the common difference, you don't have to, but I usually do. Let's start solving it. Order of operations. What is 7 minus 1? 7 minus 1 is 6. And then times 13. What happened to the 0, Mr. Carlson? It's 0. It literally means nothing. Okay, so I dropped it. 6 times 13 equals 78. Boom. Okay, boom. Now, we will start to analyze how arithmetic sequences relate to functions in the next couple days. Okay, but in this case, we do have an output here. We do have an input. Okay, the input is 7. The output of my sequence is 78. I'm going to come back to that later, but that is my final answer. What is a sub 7? A sub 7 equals 78. A sub 7 is 78. Okay, go ahead, take a moment, write that down, finish that, and we'll move on. Okay. Let's move on. I'm going to put this formula. This is the formula I'm going to use. I'm just going to keep it here. You've already written it down. You don't need to write it down again. So let's go to a more complex example, but just kidding because it's not really complex. You know why? Read. Write the formula for the general term. So this is the first thing we have to do. Number 1, we have to write the formula for the general term. And then do not use a recursion, like okay, but then use the formula. I'm actually going to use a different color for this. Let's use Spider-Man colors again because, you know, everyone loves Spider-Man. If they don't, they freaking should. Okay, use the formula to find a sub 20. What does this mean? Let's find out. Number 1, it's going to ask us to find the general term. The general term. What is the general term formula? Okay, well, I need to find my variables first, right? So I'm going to do off to the side, what are my variables? My variables, first of all, a sub 1, they tell me is 28. What is my common difference? My common difference is, again, hidden in plain sight. This right here is the recursion formula. Okay, I'm just going to abbreviate recursive formula. That's what it is. We know that this number right here is technically your D value. So I'm going to write that down, negative 17. We did that in the previous example, so go back and read through, watch it, and do awesome math. That's negative 17. I have everything I need besides my last thing. What is my n? Well, my n in this case, in red, my first step, my n is still going to be unknown. When I solve for blue, okay, my second step here, this is my second step, I do have an n, and in that case, my n will be 20. But do I have an n for my red here, my first step, the general term, the nth term? No. Now, I'll show you what I mean by that. Watch. Math Excel is going to ask you for two things. Number one, the general term, an actual formula. Number two, it's going to ask you for the actual number. What is the 20th term? So first, they want a formula. Second, they want an actual general term, a number. So first one, let's go to it. A formula. What does it mean? Let's follow. So a sub n. Now notice I'm not going to put a number here because I don't know what it is technically for my red. It wants a general term. My a sub 1 is 28 plus parentheses because parentheses. And then n, do I know that? No. We have a question mark there. Minus 1 parentheses times, because that's multiplied. What is my common difference? I'm glad you asked. Negative 17. Perfect. Now, let's start simplifying this. Okay, and you're like, how can I simplify that? Well, watch. That's why I have a job, so I can teach you. Plus, this negative 17 is still technically multiplied to this parentheses and minus 1, right? You would say, yeah, of course. That's what the dot is. Great. Can I distribute? You should be saying yes. And you're like, but you're not on the same side or the right side of distributing. It does not matter. Why not? Because it's the commutative property. What I do when I multiply two different things does not matter if I switch them up. If I multiply 3 times 2, it's 6. 2 times 3, it's 6. If I multiply negative 17 times n minus 7, or if I multiply n minus 1, or if I multiply n minus 1 times negative 17, it's still the same thing, which means I can still distribute here. So I have right here negative 17n, negative 17 times the n, okay, plus, because negative 1 times negative 17 is a plus, so I have a plus 17 here. Okay. Now, since we don't need the parentheses anymore, I can just combine like terms. What are my like terms? I have 28 and then 17, and then just the negative 17. Doesn't combine with anything. So I have negative 17n and then plus 45. What's my general term formula? This thing right here. Okay? And I'll even write that. This is what we call the general term formula. General term formula. Now, Math Excel will ask you for this. Okay? They will actually ask you for this. But I want to pay very close attention to this before we get to the second step. Now watch. Watch. Think about it. Think. What's the variable in this? There's a variable in here. What's the variable? You should say n is a variable. We don't know n. Question mark? That's what a variable means. It changes. Right? Variable means variation, or it's variable, so that means it changes. What's a variable? It's n. Now, does this kind of layout look anything similar to you? You should all say yes, because it looks exactly like your slope formula. Okay? I'll get back to this probably in the next couple of days, the next couple of videos, but think about it. Can I rewrite this as negative 17x and then plus 45? Question mark? Interesting thing is, honestly, we can. I'm not going to do it right now. I'm not going to get too much into it right now. Suffice to say, this is your answer, okay? and I'm going to explain why these are actually equal. They're the exact same. So before I get into all that madness, let's finish our problem. Let's go to 2, step 2. What is step 2? Step 2 is what's in blue. What's in blue? Find a sub 20. So I'm going to put find a sub 20. Now watch this. When I find a sub 20, could I do this formula right here? Could I do this formula just like what I did in the previous slide? Or could I take literally what I just got? Either one, because this right here equals this formula when you put all the numbers and mesh them together. So I'm actually going to take this, and I'm actually going to use that for my advantage. So watch, negative 17 times 20. Now, why am I doing it here? Why am I doing negative 17 times 20? Because n is times the 17, the negative 17. And so here, if n equals 20 now, n equals 20, right there. So that means I put 20 in for n. So negative 17 times 20 and then plus 45. When I do this on the calculator, I should get negative 340 and then plus 45. And then this equals negative 295. This is my final answer. So what is my a sub 20? What is the 20th term of this sequence? It is negative 295. What is the general term of this sequence? It is negative 17 n plus 45. Okay? I hope that makes a sort of sense. I'm going to move on and erase, and we're going to do a couple more examples like this. I have one more example where we're going to probably use both formulas. And then I have 2 application questions. And then we're going to be done. Okay, so let's erase. Ooh, did we have another one right there? No? I feel like we did. Okay, I was scared. So to recap, this is my explicit formula. You already wrote this down. Okay, this is my recursive formula. You already wrote it down. Okay, now write both arithmetic sequence formulas for the following sequence: 3, 5, 7, 9. I'm going to write both formulas down, okay, just in case. So this one isn't actually solving like what this number is, what is it. I just need to write both formulas down. So you ready? Both formulas I need to write down. In order to do that, I need a couple things, my a sub 1, and I need my d value. What's my a sub 1? It is 3, this one right here. What's my d value? You should say plus 2, plus 2, plus 2. So my d value is 2. Do I care about my n here? I actually don't care about my n right now. I'm only considering the formulas, not actual numbers. If I cared about actual numbers, if they gave me find this, find the 15th term or something, then I would care about n. But in this case, they don't, so I don't care about it. I'm going to keep n in the formula. So first thing, I'm going to find my explicit, and then I'm going to find my recursive. Let's go to step 1. What is my explicit? I'm going to write it down. A sub n equals, what is a sub 1? We already said 3. Okay, it equals 3. Plus, right, plus, I have, right here, n minus 1. So what's my n? My n is nothing. I'm going to leave it as it is, minus 1. And then what's my d? My d is 2. Okay, let's simplify it. Remember, I can distribute. So this is 3 plus 2n minus 2. I can simplify by combining my like terms. So 2n doesn't combine with anything. 3 minus 2 is plus 1. So this is my general term formula. Okay, this is my general term formula. Boom. Now, what is my recursive formula? I'm going to write it down, pretty much copy it, almost word for word, letter for letter. And the only thing I'm going to really change is this plus d here. So what's my d? Plus 2. That is my recursive formula. It's actually that simple. So if it asks you for the recursive formula, boom, there it is. If it asks you for the explicit formula, boom, there it is. Okay? That's how you solve. I hope that helps. Let's go through a couple application questions and then we'll be done. These application questions you will see on your homework. Let's erase. All right. Okay, let's try to finish this first example. So in 1981, approximately 10% of all adults had no close friends. That's pretty depressing, actually. On average, this percentage has increased by approximately 0.72 per year. I assume that's percent, but 0.72 per year. It's also extremely depressing. So first things first, I want to notice a couple things before I list out my variables. The first thing I notice is it's in 1981, and on this graph that they give us, they say 1981. So am I concerned with the 2005? That's a no can do. I'm not concerned with that, so I'm going to scribble it out because I don't care about that. I'm only concerned about the 1981% of adults without close friends, and in this case, it's 10%. So I'm also going to underline that here. Now, on average, they say, this percentage has increased by approximately 0.72. So when I read has increased, that will signify or should signify that this is actually my common difference. Each year, it has a constant difference or addition of increasing 0.72. So this is 0.72 per year. Okay. Now, what is my a sub 1? My a sub 1, again, is hidden in plain sight. If this is 1981 over here, looking at my graph, where do we start? We start at what the percent is in 1981, and in this case, the percent is 10%. So I'm just going to write 10 right here. Now, they don't ask us what general term they want us to find. So in other words, they don't say, given this year, what is the percent? So do I have an N? I don't have an N, okay? I actually don't have it. They don't ask us in any given year, what is the percent of adults who have no close friends, okay? So really what they ask us is, first of all, right now, they ask in the first step, what is the general formula? Like, what does this formula look like? I'm going to use my normal explicit formula, a sub n equals a sub 1 plus parentheses n minus 1 times my d value. So I'm going to cloud this. This is not my answer. That's why I'm clouding it. It's not a box. My answers are boxed, not clouded. So this is a formula that I'm going to use. So a sub n, do I know n? Again, I don't, but that's okay. It's not asking for it right now. So a sub n equals, what's my a sub 1? This is 10. And then plus my n, again, we don't know it, minus 1 parentheses times my d value, which in this case is 0.72. So let's start simplifying this stuff here. If you want to put parentheses around this 0.72, that's fine too, if you want to do that. I have to distribute that through, so this is plus 0.72 n, and then minus negative 1 times 0.72 is 0.72, tag on the negative. Okay, so this is what it looks like. I simplify, so now what I have is 0.72, because I simplified the 10 in this, but I don't simplify the n term, so that's just chilling, okay? And when I combine the 10 and then minus 0.72, I actually get plus 9.28, okay? This is my general term formula. This is my general term formula. So that's my first answer. Now, it doesn't say in the actual problem what year to find any given percentage, but I'm going to add that in. So let's just say in my second step, Math Excel will ask you, what about in 2006? So let's just say this. Again, the question doesn't ask this, but I'm just going to go off, and let's just say, what about in 2006? How many adults have or not have close friends? Okay, super depressing when you think about it. How many adults don't have close friends? Let's find that percentage. Okay, in 2006, how many adults don't have any close friends? Let's use this formula. Now, first of all, the thing I need to notice, again, is 1981. We started with 1981. If I want to go from 1981 to 2006, how many years have passed? Okay, how many years have truly passed here? So I take 2006 minus 1981. How many years does that give me? This gives me 25 years. Is this my answer? No. But what it is it's actually my n value. So in 25 years, how many adults without close friends, what's the percent that has raised, that has increased? Okay, so let's try to find this out. So a sub 25. I'm going to put that right there, a sub 25. And then I'm going to use this general term formula that I just found. So 0.72 times 25 here. And then I'm going to plus the 9.28. Okay, so 0.72 times the n 25, the n 25 plus the 9.28. What does this equal? We can actually plug this straight up into our calculator. We can plug it into Desmos if we want. Okay, so make sure you maybe have Desmos pulled up so you can actually look at and just type it straight up as it is right in. When I do this, I get 28.03. Now, technically, this is percent. So how many adults had no close friends in 2006? What's the percentage? 28%. As opposed to 10% in 1981. That is super sad. Okay, I don't know about you, but I'm not part of that category. I hope you aren't part of that statistic in 25 years. Okay, moving on. Make sure you pause the video, get this stuff down. That is how you do that question. Let's move on. I'm erasing. Okay, this is my last example, my last application example. You'll see probably something like this on the homework quiz the next day, or definitely you'll see on the homework. So first off, you have two companies. You have company A. Let's just say this is green. Company A pays a yearly salary of $25,000, which really is awful, with raises each year of $1,400. Okay, so that's company A. Let's call company A Starbucks. Okay, Starbucks, because why not? Let's see if Starbucks, so A, is better than B. Let's call B, company B, Dunkin' Donuts in red. Whoops, I'll just say donuts. How about that? Okay, so donuts. Let's see which pays better, because let's just say you can't do any better than Starbucks or Dunkin' Donuts. Okay, so company B pays $28,000 yearly with yearly raises of $850. Okay, so each company starts out with this yearly salary, and then each company gives a yearly raise. So what we want to find is which one will pay more in year 10, and then also how much more. Because let's just say you have two companies that really want you, Starbucks and Dunkin' Donuts. Which one are you going to go after? Well, you need to do math, of course, because that's application stuff. So A, pay company A $25,000. What is that? So let's list out our variables. $25,000, you should be thinking, is my first term. I start with $25,000. Now, what is the 1,400? What is that? That is actually my common difference. It differs or increases yearly by 1,400 or $1,400. So I'm going to put 1,400 here. Now, remember, I'm going to put up to the top in blue. This is my formula. A sub n equals A sub 1 plus my parentheses n minus 1 times d. This is my explicit formula here. Okay, that's my explicit formula. So when I start writing it, now I'm going to do green because it's Starbucks. Watch, I have A sub something. What is that something? That something is year 10. I want to know in 10 years, how much will I be making at Starbucks if I get a yearly raise, guaranteed a yearly raise of 1,400. So that means a sub 10 equals, what's my a sub 1? We said it was 25,000, so I'm going to write it there, plus my n we said was 10 minus 1, and then my d we said was 1,400. So let's start simplifying. This is 25,000. If I've been saying 2,500, I apologize. 25,000 plus 10 minus 1 is 9. And then times this by 1,400. Now, I'm not going to do all the math here. You can definitely do all the math and multiply this all out if you need to. So multiply it all out. You should get $37,600. Because again, we're trying to find dollars. So if you go to Starbucks, you will be making, after 10 years, $37,600. That still kind of sucks, to be honest with you. Okay? Now, how much will I be making in Company B, Dunkin' Donuts? See, it's Christmas colors. It's beautiful. What is my a sub 1? My a sub 1 is 28,000. That's what I start with. That's where my sequence starts with. My first term, a sub 1, 28,000. What is my common difference? What's the yearly raise that increases per year? 850. So let's start going to town on this. N will continue to stay 10, so I'm going to actually write that here. So N equals 10, because I still want to know in 10 years how much will Dunkin' Donuts pay me, Company B. So in 10 years, a sub 10, my N is 10, equals my a sub 1, following my formula there, is 28,000. Just following my formula. I'm not making this crap up. Just 28,000. Plus, because my formula says plus, parentheses, what's my N? 10 minus 1. Again, part of my formula. And then times D. What's my common difference? 850. That's how much I'm being raised every single year. When I simplify all this, I'm not going to show you all the math because, of course, you can just plug straight up this whole thing into Desmos, and you can do it. If you don't believe me, I will do it right away if you really want me to, but I don't need to. You can plug that into Desmos. You will get a yearly salary at year 10 of $35,650. Okay, I hope I'm not wrong there. My notes kind of look skittish. I don't think I am though. So $35,650. So that's the question. Which one pays more? Of course, freaking Starbucks, because it's amazing. Okay, so that means Company A or Starbucks pays more, and that's what we're going to write. And so that means you will want to go to that company. How much more? Because that's what it's asking. So let's do that in blue. How much more are we being paid? All we have to do is take our two answers and subtract them. So 37,600, and then minus, I take 35,650. And you can just plug that straight up into Desmos. In fact, I'm just going to show you now because I keep saying that, but I never actually do it. So I'm going to show you. We're going to take that. If you just go to Desmos.com, if you're not using Desmos because it's free, you ought to. I should be a freaking sponsor for Desmos for how many kids I actually guide their way. Come on. Is it just not? Okay. So when you're at Desmos, you can use it as a graphing calculator or you can just use it as a straight up regular calculator. So 37,600 minus, if I go back, I have 35,650. So I'm going to go over here and I can just do minus 35 and then 650. And this will give me the amount. Okay, so that says $1,950. So I'm going to go over here. I'm going to write $1,950. That is how much more is being paid. So plus how much more being paid in year 10 on Starbucks, almost $2,000 more. Okay? Again, this is how you do it with Desmos. You just plug it straight up in. Okay, so that is the last example. I'm going to clear that. Let's go over here. Make sure you pause the video so you can get this. Por favor. I'm going to erase. Oh man, can I not erase the whole thing? Is this not? Okay, so what did we learn today in arithmetic sequences? We learned a couple things. We found the common difference of an arithmetic sequence. What is that? It's how it increases or decreases. It's that number that's that constant ratio throughout the whole sequence. That's what the common difference is. We label it D. So we found how to find that and how to use it. We also learned how to write terms of an arithmetic sequence, how to find general terms, how to find specific terms in the actual sequence. And then we use the formula for the general term of an arithmetic sequence, again, to find particular terms. All right, so your closure, your homework, just review your notes. Make sure you are writing your notes in Cornell note style. It helps. It really does help. Get that content down, get those notes. Make sure you write the summary. Review them as you actually complete your homework tonight. Okay? It's so helpful. Use them as you're completing your homework. Okay? So you're prepared for the homework quiz tomorrow. So all you have for homework is just your arithmetic sequences on Math Excel, or if you're in honors, do your honors assignment. Remember, if you have yet to do any of the Desmos activities, okay, go back to the previous videos, rewind this video, and then find that Desmos activity. I show it. Those are past due. I graded them on Friday. Make sure you complete them so that they are no longer missing. If you have any other missing assignments, make sure you communicate to me and then get them turned in ASAP. Remember, all assignments are due by Thursday at 4 p.m. Thursday this week, because we have the teacher in service, Thursday at 4 p.m. If you have any other questions, let me know. I'm going to sign off. I'll see you guys later.